Each new season in FIRST robotics competition is an experiment. Leaders change, students change, the team changes, but we always push towards the execution of a design. The truth of FRC is that an effective team develops the best of its parts into a greater integrated whole. On Team 422, we have been taught that the first step of design is defining the problem so that the solution can be compared to the initial state. After the 2017 season, we determined that a lack of skills and restricted participation in the design process had limited the effectiveness of our robot. Our 2018 goals were to improve communication and increase involvement on the team in order to address the lack of team cohesion that hindered our success last year. During the off-season, we ran orientations for all the sub-teams that worked together to build the robot. We introduced build room tooling, certified team members for safety, practiced control systems planning, developed drive-based code in C++, and modeled components in Fusion 360. The team also practiced strategic design through game demonstrations, mentor and officer presentations, and FRC history group projects, which archived the best robot designs between 2005 and 2017. These activities served as teaching and learning moments for the team to work effectively in small groups, practice problem analysis, and become familiar with FRC and each other. By developing the team's problem-solving and technical skills through hands-on experiences, 422 built the context in which our team could be the environment where collaboration and education meet technology, and where everyone can contribute to innovation. Among the many changes to the team's organization and design communication methods was the student leadership's decision to implement Autodesk's Fusion 360 CAD, CAM, and CAE package as our standard workflow. Most importantly, we chose this program because it encouraged collaborative design and facilitated the needs of our technical team to access models from home through Autodesk's cloud services. During the build season, CAD designs were prepared at home, discussed during the school day among the technical leadership, and delivered to the manufacturing team at the start of meetings. The new workflow allowed safety-certified team members with less experience to contribute to more of the work being performed at meetings. It also enabled the build subteam to communicate with the control system subteam to develop the electronics and pneumatic system, and with the programming subteam so that we had code ready to load onto the robot immediately upon mechanical completion. The increased efficiency and centralization that the cloud services provided was used by the technical team to complete our practice robot, competition robot, and a complete set of spare parts before bag day. In FIRST PowerUp 2018, Team 422's design began with the definition of the minimum competitive concept, which we determined was a robot that always moved effectively, crossed the line in auto, and could score in the vault. We then defined an effective alliance member as a robot that was able to control the switch. In our design, this meant that we developed an articulating intake that was not reliant on an elevator to score. To win a majority of our matches, we determined we had to effectively control the scale, so only after beginning development of the intake did we begin to develop the elevator. In order to maintain our priority list, and by virtue of its strategic and realistic benefit, we developed a handoff between our intake and our elevator that allows us to control the switch regardless of the condition of the elevator. This keeps our center of gravity lower, decreases the moving mass of the elevator, allows faster elevator cycles, and limits the amount of wear experienced by the motion components on our elevator. In order to score on the scale, the handoff mechanism consists of a passive Garolite plate and a pneumatically actuated polycarbonate and aluminum kicker, and was inspired by the escapement mechanism used on most mechanical clocks. The materials were chosen for their low weight and were optimized for rigidity. When the piston actuates positive, a finger on a hinge is pushed down to hold the cube against the plate. When the piston actuates negative, the finger is pulled up and two prongs kick the cube off the plate and onto the scale. Altogether, the components weigh less than 2 pounds, which allows the elevator to travel at 8 feet per second, and at our first competition, this low weight and high speed was a benefit as we battled for the scale in critical qualification matches. The assembly also secured the cube on 5 sides using the elevator, intake, plate, and kicker assembly for consistent control and delivery during the autonomous and teleoperated periods. The high-speed transition onto and off of the elevator made quick changes in strategy during match play possible. Our reliable drive base, robust intake, and fast elevator were controlled by our highly practiced and well-prepared drive team to effectively control all 3 of our initial design priorities throughout our first district competition. In the teleoperated period, we consistently protected the switch, filled the vault, and assisted with owning the scale. As Alliance captains, we went undefeated in playoffs using advanced scouting, an aggressive strategy, and effective communication between the drive teams. Team 422 carried our culture of effective communication and teamwork behind the glass and throughout our competition, and the results speak for themselves.
Congratulations to our Alliance captain, Team 422!
The Mech Tech Dragons, they're from Maggie L. Walker Governor School in Richmond,